we're going to be doing some more debugging today, hopefully also adding in a bug fix of we know we need to fix the scenario where if there are only capstones or standing stones around us, we don't want to be able to pick up our stones because there's no legal moves here. We can't move in any direction. Yet we can't drop all of our stones. So we're just perpetually stuck there. So we need to figure that out. But then on top of that more, I was also thinking we also got to do right now we have it where there's a maximum of 10 stones in a stack. And where that screws us is if we're moving into a space with 10 stones in a stack, we can't place any stones there. So like we would have to limit it so that we only have the 10 stones. We might have something saying that we can't drop a stone if it's already occupied with 10 members or something like that. But we need to implement something to prevent that from getting stuck as well. Now, I'm kind of curious how this 3D tech game right here, how they're handling things like that. I was avoiding looking that up because I wanted to see if I could build it myself. And I think I've proven to myself that I can build at least most of it. I'm tempted to look it up and see if they implement a stack limit. Maybe we'll see if they implement a stack limit here. Never actually done this. Okay, nice. So oh, you have to play against somebody. Maybe that's why I haven't played. I want to play locally. Okay, well, since I would need to test it, we can't really test it if we play a live game. I don't really want to do that, so we're just going to figure it out ourselves, like we've been doing. I'm curious what a 10 stack with a capstone looks like. Let's see what that looks like. We'll turn off our 3 stack tester. We'll turn on our 10 stack tester. And we'll make sure that the top stone is a capstone. We need stone control as well. Okay, so here's what a highest stack would look like with the capstone on top. Okay. Yeah. So it's like, do we want to go any smaller than that to allow maybe even 12? Maybe even 12 to be stacked? I don't exactly know. Because even if we allow 12 to be stacked, then we still have to come up with, for example, let's just see what happens if I give ourselves, let's just give ourselves a 3 stack next to this next to the 10 stack, and we'll try moving on top and see if we are limited because of the amount of occupants, or what the render might look like, or if the logic just totally breaks. I could just control find replace these, but there is some logic in our legal moves where we hard code in the grids, and I just don't want to overwrite any of those values, so I'm kind of just doing it the stupid way. Okay, so let's see. So if it's black's turn, actually we can't move on top of a capstone, so we would have to change it back from a capstone. Let's just say it's a laystone. Now it's black's turn. Let's say we're going to lock in a direction. Now look, there's 10 occupants here. We're limiting it to 10 occupants, so if we click on there, dropping index is a nil value, so we can't place any stones on top of a 10 stack, which is game breaking. In the original game, the real game, there's no limit to how much you stack, but in this game, since we're limited by a 2D representation, I decided that we needed to kind of render them smaller in order to see them stacked, and then that means that we have to choose how small we're going to get for legibility purposes. So I chose a 10 stack limit. Now let's take a look at our drop stone. I don't see anything to do with the amount of occupants that are in our new place, except actually it's right here. So look, we increment our occupants, right? So we have a parameter occupant, we pass in the grid we're trying to dump in, and then we're saying that occupants field will get incremented by 1. But if you take a look at when we initialize all of our occupants, we do it right here. We only do it for a actually no, this would be, where do we populate the occupant field? Trying to figure out why it exactly crashes there. Shoot. Let me see a control find dot occupants. When we might assign those things. Kind of confused. Where we kind of... Occupants is just a value, a integer. So it's not like it was a nil value. Yet we've crashed at 236 attempting to index it. So, okay. It's because when we dump a stone, we insert our mouse stone into a variable called the occupant index, which is an index of our members, which is a table, just like everything in Lua, and the index there is no members 11 index because we populate our members table with member instantiations, which is here. A member is a stone color, a stone type, and a stack order. Original stack order and position, but where do we exactly do this? Where do we populate our members? Right here. Right here. There we go. Gives us memory for 10 member objects in each occupant instance. So if we were to, for example, put this at 11, would we be able to drop a stone into a 10 stack? This isn't necessarily what we want to do. It didn't render it, but it did allow us to drop it. It's tricky because I don't know what I want to do. It's kind of game breaking in a sense. Because if you're trying to move, like a 10 stack becomes a 10 stack in our version of the game kind of becomes a impenetrable fortress, which changes how the game is played. I don't know how often games get to a whole 10 stack, but I feel like I've seen it before, so it's not like really unheard of. Why weren't we rendering it though? Kind of curious why we weren't rendering it. Even though we dropped it in there, it allowed us to drop it in there, right? Like, so look, there's 10 occupants in that grid right now. There is 4 occupants in our mouse stone right now. And if we drop one, well, now it's, I changed it back. Here. That's a lie. Okay. So, we've got 10 occupants in our grid, 4 in our mouse stone. Now we have 11 in our grid, 3 in our mouse stone. So it does drop it there, it's just not rendering the white stone we just dropped. I'm kind of I don't know what to do. I feel like maybe we call our max 12 and just hope that we don't get 12 stacks very often because it's kind of obnoxious. There's only so many stones and you kind of lose stones in the stack, so I don't think it'll be that common to have 12 stones. So if we could shrink, you know, if a 12 stone stack is still readable, legible, then I think we should allow that and then call it good, and then we'll have to make sure we limit the moves. So like if your only legal move is going to be on top of a 12 stack, you can't move it. I don't know what to prioritize there. I guess. I'm curious why it doesn't render. What are we doing that we only render 10? Oh, you know what? Yeah, we only render 10. That's exactly what we do. If we go to our render function, where we render, yeah, we only render 10 stones. So if we render 11 stones instead, does it render 11 stones? It does not. We really should change this to stone max so that we don't run into this problem. If we'll do it manually here and then we'll change it. I'm just trying to get it to render that stone, that 11 stone. Nice. Okay, so that 11th stone will render. I'm curious what a 12 stack would look like, because I feel like 12 stack is a bit ridiculous. So if we allow it to be a maximum of 12, maybe we're okay. And then we can just limit movement on a stone. That would be that big, I don't know. So let us see if we can now drop 12 stones in our stack. So this used to be the limit, 10 stones, but now we can do 11 and 12, and it's still pretty legible. I mean, you can read that that's a square. So I'm wondering if if we drop one there, pass over it, and then put a black capstone right here, and we move our black capstone on top. It's a little less legible, but you can see that there's something on there. Let's see if a standing stone is legible on a 12 stack. So we'll drop one here, and then we'll put a black standing stone, and we'll try to move that black standing stone on top. Huh. Why did that one not render? It was black, yes. This should crash it. How come we didn't render the standing stone? We can move a capstone onto it, and it seems to be fine. Yet, when we try to put up, we want to put a black standing stone on it. Why does it not render the standing stone? I think our logic is just not built for it. Our logic in our standing stone render, like right here, we've got this shrink, all this logic, something's going here, where if it's a 12, our logic is just busted for our standing stone at least. Took us a while to figure out this logic. But see, like I don't even know what what variable to tweak. This is our X. This is our Y, which I think is fine. It should just be the width and or height that is messed up. Let's say we give ourselves, I don't know. Let's just say we give ourselves 5 bigger on the width and height just to see if we can render that. It'll probably mess up all the stuff. Otherwise, yeah, see how it's going over? It's going over now. But I just want to see. Let us move. What the heck, dude? Why would this be? Why is this illegal move highlight true? Why? Okay. Let's put a black lay stone, try to move it on top of an 11 stack. Yes, now we can kind of do it. So it is something to do with our render logic here. That just makes it not adaptable for a 12 stack. So if we figure out what that is, we could adapt. Does our shrink need to be a bigger value, maybe? A slightly bigger value? I'm looking for our constants. Shrink is 10. What if shrink was 9? What does that look like? Okay. So let's see if a 12 stack renders on a shrink of 9. Now, yeah. It doesn't look exactly square, but maybe it is. I can't tell. It looks almost like an optical illusion when it's stacked like that. So now it's a little harder to tell. Yeah, I feel like be allowed to put decimals here. Would that mess it up? So look at this. That looks a little offset. Looks a little off-center, right? It's hard to tell. I can't tell if that looks off-center. It looks a little off-center to me. Let's say we put this here. And then... Okay. That's very thin, but yeah. Decently legible. It just doesn't look centered. It looks, actually, I don't know, it looks centered when you zoom in. It looks a little high, I think. It's hard to tell. Just out of curiosity, what does a shrink 8 look like? That's pretty legible. That's pretty darn legible. With that size, we might even be able to get 13, a stack of 13 if we really wanted to. Let's see what a capstone looks like with a shrink of 8. Legible. Very legible. That might be the sweet spot. Are we okay with having 12? Should we go for... Because it's like, you know, looking at the games that have been playing over here, I don't think anything's been more than a 12 stack. Right here we've got a 7 stack, and that looks pretty high. I guess if we kind of scrub through... Look at that stack. How much is that? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stack. That's what we currently are able to render with the black capstone on top. Just like we've got right here. We've got a 12 stack with a black capstone on top. But see, in our game, well, and see, normally in games, the capstone tends to be on the highest stack. So once a stack gets high enough, a capstone can capture it, at which point there can be no more stones on top of it, and your capstone isn't likely to give it up. So 12 might be good enough. It's just hard to say. Let's see if this game has anything higher than a 12 stack. Doesn't look like it. I'm trying to find out like what the reasonable number is to limit our stacks to, because we don't want it affecting gameplay. Ideally, we don't want it affecting gameplay. It's just a limitation from our 2D representation. And if 12 stack is good enough for these championship games on a 6x6 board, it's probably good enough for us on a 5x5. You could technically break the game if you just go willy-nilly and try to make a 13 stack. See, like right now, this thing, come on. Yeah, this is only a 6 stack, and we can go twice as high as that. Whoa, getting taller. So look at this, was a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stack. Okay, so 12 stack for our 5x5 grid is probably a decent limit. Do we try to see if 13 is legible as well? Because if we can get away with 13, might as well do it. Let's see. The 12 was looking really nice. I'm curious if the 13 looks okay. And if it does, then we'll see. We'll see. We'll change this. Let's see if we can do a 13 stack. So we're going to say drop 2 here. Then we're going to drop a white capstone and move that white capstone. That's pretty legible. I mean, you can see that our capstone for a 13 stack might need to be a bit smaller. just a tiny bit smaller on our shrinking logic. Is 12 okay, or should we go for 13? I feel like we should. We don't want it affecting gameplay, so the higher we can go, the better. I feel like as long as a lay stone. Let's see if our standing stone is legible on a 13 stack, and if it's not, we'll just stick with 12. So we'll say 2 stones there to a 12 stack, and then we'll put a standing stone and see what that looks like. And it's legible. So I say, let's see if we can't figure out the scaling for a capstone on a 13 stack, and if we can, then we add in a constant of max stack amount and limit it to 13. And then we still have to figure out how to limit the player from being able to drop stones on it, or from limiting a move where the only next move is on top of a stone of that many. There's a lot of things to keep in mind, because let's say it's a 12 stack and you pick up a 5 stack right next to it. You could technically, you couldn't dump all 5 onto that 12 stack, but you could technically put 1 stone on that stack, pass over it, and then drop other ones, because you're not passing the limit at that point. But I don't know how we want to do that, how we want to limit the player's moves like that. Ideally, we don't have to do that, but I don't know what else to do. We can't make it go forever like the real game. And my reasoning for it is, like, in the original game with the pieces, you're not really going to stack more than 13. It's going to be really unwieldy. So let's just worry about the scaling for our capstone. Now, for our circle, it's an X position, a Y position. No, what is it? What is the love.graphics circle function? Radius. So we want the radius to be a bit smaller. So right now the radius is our capstone height minus our stack order divided by 3. So what if we divide it by 4? And see what that looks like, at least on a 10 stack, then we can test the other ones. Or a 13 stack, actually. So there's a 12 stack. And then now we're gonna how is that bigger? How is that bigger? Why was that bigger? Let's see. Okay. I am really just guessing at this point. We know it needs to be smaller than 3 for a 13 stack to look so believable. So let's see. Hey, perfect. That's looking good. Now the question is, does every other capstone size look okay? So here is it on top of that, which looks okay. Let's see what it looks like if we have a 5 stack. That looks okay. Looks pretty good. Let's see, maybe on a 7 stack. There's a 6 stack. There is a 7 stack, and we'll put our capstone on the 7 stack. Looks pretty good. I think I'm happy with that. So we're looking pretty decent for a 13 stack at this point. So we've increased the max stack limit we can hold in our game from 10 to 13 to hopefully minimize problems, because we can't render any stacks higher than a 13 stack because it just gets unlegible. Part of me is curious to see if we just try for 14, and if that's legible, it'll make it even less likely that we need to incorporate a fix for that. Let's see what our 13 stack. Let's see if our 14 stack is legible. I don't think the standing stone will be legible at a 14 stack, but if it is, we'll check the capstone, and then that'll be our limit. Let's just see. So this is a 13 stack at the moment. Actually, okay, there's a little bug going on. If your mouse is over the movement origin grid, by the time you lock in your stones, it kind of stays lit until your mouse hovers over it. So we should kind of flush that so that bug isn't there. But let's see if a 14 stack standing stone is legible. It's tiny, but I guess it's legible. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. 14 is technically legible. It doesn't look as good as the 13 stack did for that standing stone. So let's see. 1, 2, 3. And let's see what a capstone looks like on a 14 stack. That's legible, man. That's legible. It's just our lay stone, our standing stone rather, that I'm not so happy about on a 14 stack. Let's see if we can figure out standing stone adaptation. So here's an X and a Y. I think those should be fine. Same. It's just that we don't want to shrink it as much. So it's hard to, because I don't know what these values evaluate to. But what if we just increase our size by about 0.5? Probably throws off all kinds of stuff. Still doesn't look that great. Just looks so tiny. It should be wider. So what if What if we say this is... I'm just gonna add a +1 to both of these things to see how much just one affects it. Then maybe we'll see. Come on. See how the +1 overlaps it over there. So can't tell if that's looking better. We just want the height, really. We don't want the width. That's looking better. Looks like it's offset. It is a bit thicker, but it looks like it's offset. Width and height. So if we don't mess with the width, we just swap the height a bit. It's looking better. They just look chunky. It's looking a bit better. See how that just doesn't look even for the Y position. Oopsie. Really don't know how to modify this and keep it centered, because this was a lot of testing to kind of get the shrink proportions just right, because we programmed it for a 10 stack thinking that's going to be the end of it, but I didn't foresee these problems back then, and giving us 4 more occupants, 4 more members in each occupant, puts off the possibility for error, because it's not so often that we'll get a 14 stack in a real game. So hopefully that won't impact the gameplay. Now, why is this +60? What if we just +50? I don't know what that 60 comes from. See how it looks offset now? The black standing stone is really high, but... oh yeah, it's even worse over there. It's so jacked. So jacked. Really, 60 is the sweet spot. Maybe 60 is half of our standing stone height or something. No? Maybe we... it's hard to scale it and center it with just logic. Yeah, I don't know what to do. It just seems so off. Does +60 look perfectly centered? No, it doesn't. '55 looks a bit too high. That's looking pretty close. Let's see what our 13 stack, or 14 stack actually. That's looking good. Okay, I'm happy with that. That looks centered. That looks centered, and we've got a 14 stack. And it's legible. And if we place a capstone in a 14 stack, see, that's that bug I'm talking about. It doesn't reset that. Now, why is that? Why is that Lego Move highlight true there? I don't know. We'll have to see if we can replicate that. Because look, it's going back. Lego Move true. That's weird. That's weird. It doesn't allow you to move incorrectly, but okay. Capstone in a 14 stack looks pretty legible. Let's see if we can. Well, first of all, let's give us a constant called max stone height. And max stone height gets 14 at the moment. So in our place state, instead of typing 14, we just type in our max stone height. And then do the same for our others. Now, if we were a good programmer, we would have done that when we first did that variable. And then when we wanted to test what we did today, all we would have to do was go in our constants and give us more max stone height. But I didn't foresee us doing more than 10, so I didn't bother with it. But, you know, that's how you learn. So we've added 4 occupants to our max stones. We used to only have 10, now we can have 14. We still need to worry about the render of the shadow of the stacks, which I still don't know how to do. Because look at this. White stone, white stone. We move a white stone on top of a white stone. Looks no different. It does say there's 2 occupants, and if we were to select it, we could drop one. Actually, hold on a sec. We should be able to drop a stone here. Oh. We already locked it in. Hold on. Okay. So look, we pick this up, we drop a stone, then we lock it in. Okay. So what I was trying to show was, let's say we're here, white on white, you can't see shit. We need to fix that. But if we were to pick it up, we could drop one of them and see that we have, in fact, a smaller stone right on top of it. And then we can move that. So there were 2 there, you just can't see it. So we need to add a little black or a little gray outline to each stone. So how do we go about doing that? We take a look now, I've got an idea that might work. For now, let's only worry about lay stones, and let's try. Basically, what we're going to try to do is we're only going to worry about white lay stones at the moment, because I'm just going to try to see if this works. My idea is we take the same logic for rendering our stone, except instead of rendering white, we're going to render gray. And then right above that, we're going to render white a tiny bit smaller, like, you know, one less pixel on the width and the height. But then we need to offset the X and Y by 1 pixel as well. So let's just see if it's tough. My brain's like starting to break thinking about it. I thought we were going to be doing debugging today, but instead I went for some feature implementation, which is fine. Because part of the debugging was going to be, I was just imagining all these scenarios where moving on top of a 10 stack would cause all these problems, because as you saw when we first tried to index, when we first tried to drop on a 10 stack, it would crash. Which is still the same if we try to drop on a 14 stack right now. So we haven't really fixed it. We just gave ourselves 4 more turns of buffer. 4 more stones of buffer. Now we're doing our stone color here, which is fine. I'm just gonna see if my idea will work first. So when we render a white stone, the first thing we want to do is actually set our color to black. And actually it's not black, it's gray. So it's something like, what's half of 255? 125, 127. So what if we do a gray? And we first render the whole size of us gray. Then what we do is render slightly smaller the real color. So we'll have effectively a border. So instead of coding like, here's the code for the left side of a stack 4, and here's the top side of a stack 4. What we're doing is like, hey, we know how big a stack order of 4 already is. We're rendering that whole bad boy gray. Then we're going to shrink a little bit and render the real color, giving us the border on all sides. So we're covering up most of the first thing we do, but it's not a big deal. It won't cost us much in processing power, because there's not a lot of things changing in our code. I do want to ask what color we are. And set our color appropriately. And then we are going to offset our X by, let's say, 2 pixels. You know what, let's say 5 pixels for now, because I want to see if it works. 5 will be easier to see. So we're going to give our X 5, we're going to give our Y 5 offset, and then we're going to shrink our width and our height by 5 as well. So we're going to shrink our width and shrink our height by 5, and let's see if we render. That actually looks pretty cool. Totally jacked, but okay. It's only rendering. Yeah, we need to shrink it by twice as much maybe on the width and height. Oh, shrink it, not add it. Oh, we did it. That's wrong here. So let's shrink it by 10 and shrink this by 10. And we'll see if that gives us a border. It does give us a border. Now, instead of 5, what if we give ourselves just 2 pixels worth of border? So we're going to say this is now 2, and it's 2 on the y offset as well, meaning we need to shrink by 4 on both the width and the height. Okay, tiny border, right? Tiny border. Now watch this. Move a white on a white. You can see white on a white now. It looks like it looks kind of like a mess. Looks like a mess, but I'm thinking just 1 pixel and 1 pixel of the opposite color. Let's see what a 1 pixel outline looks like. Very subtle, very subtle. Now let's see what a white on a white would look like. You can read that. That's legible. And let's see what a black on black would look like. Legible. Now, and it doesn't throw off this one too much. I'm thinking white has a black outline and black has a white outline. So we're gonna say this is, and ignore how messy this is gonna be for this part. I'm just trying to test it. If it's white, we're setting it to black outline. And if it's black, we're setting it to white outline. We'll see if that adds the legibility. Should be only 1 pixel of the opposite color as a border. Nice. Black looks a little, I guess it's okay. So look, black on black. It looks, yeah. I got another idea. I don't really like how this is looking. It definitely reads, but it looks like, see how it looks like a black is on a white stone, and we don't want any, I actually don't have an idea. I was gonna say we can do a gradient. So a black on black would get slightly lighter, but then at that point, 10 stack or a 14 stack would be gray. And same with a white would be a gray, so they would look indistinguishable. I'm not really liking this. It definitely adds legibility. It's just I don't like how it looks. So that's 3 white stones and the black. Yeah, maybe we go back to gray. Gray was looking better, I think. colors, you know. If we set our border to be 50 RGB, it's a bit more subtle, yet readable. Black is harder to read than the white, but it is looking better. I'm not displeased with that. Maybe I want it to be a little, yeah, instead of the same color for the same bricks, I think we do the minimum. It's like for white, what is the minimum amount of what color we can get without it being imperceptible? So we'll kind of do it, because instead of just doing the same border color, black is different readability than the white is. So that's looking, maybe this needs to be 220 or something. We're looking for the white border, and we want it to be subtle. See how dramatic the complete opposite color border is, yet it kind of rolls off. There's a little bit of gray right there in the white on white, which is barely legible right there, but it is legible. Maybe we make it a bit more legible than that by bringing this down just a bit, maybe 210. Because yeah, that black is just too legible. It looks like it's a black on white stone. And that looks like a white on white with a tiny outline, which is readable enough for me. So yeah, what I'm talking about here is like, we've got a white stone here, and a black stone on top of it. See how the dramatic white outline looks awfully similar to a black on a white stone. So we're trying to minimize that difference so that this white one doesn't look like it's a white on a black stone. It just looks like with a gray border. So we just want to turn our black border maybe 45 pixels off from its original color, so it has difference but not exaggerated difference. That's looking not too bad. Let's see what a black on black looks like. I think I'd like it to be a little bit more legible than that. I can see it, but it's just a little hard to see. So let's say this is maybe 65. Okay, there's a white on white, looks readable. There's a black on black, looks readable. And none of them look like they are stacked on the opposite color, because the border color is a gradient of gray. So it's not the opposite color. So it looks pretty readable to me. I mean, it's subtle, but I want it to be. I don't want it to look exaggerated, because it takes away some of the beauty of it. That looks much better. So look, there's a 3 stack now, and we can actually read them. That's looking good. That's looking good. Now that's just, we don't, since you can't stack standing stones, we don't need to do that. for standing stones or capstones. So all we have to worry about is lay stones. So let's say that this is okay, so we've got this line of code twice, right? Which is setting our appropriate colors. Now we do it here because we need to set it for all these ones for our capstone and standing stone. So let's just put that down there for that. Actually, shoot, man. Because yeah, we set our color, then we have to overwrite our color before we actually render it. Because this is rendering the outline, this is rendering the actual stone. So as gross as it is, it kind of makes it makes sense to have it duplicated like that. But what's to do? Because if we take it out of this loop, or we take it out of this, it doesn't get set for capstone or standing stone. But we need to set it because we set our border colors. So maybe we have a see, and the way graphics work is you have to set the color manually before you do it, so we kind of have to do it somewhat like this. It's just so ugly. I'm going to say that this sets color for standing stone and capstone. This sets color for border, for lay stone border. And then we're going to say this sets actual color, resets actual color, because we have to change our color in order to render our border. We gotta resets actual color. And then this is renders border, and this renders actual stone. It's gross. I don't know what else to do about it. Because the way graphics work in Lua, you gotta set the color. And you can only have one color set at a time, so you kind of have to do it like that. I don't know. I'm sure there's a better way, but I'm impressed we got that done. So it's hardly noticeable, you know, when you just have one there. Look at that tiny gray border, and a tiny gray border on the white as well. It's hard to see. But it allows us to stack them and still see a white on white and a black on black. That's awesome. Cool, and now we can also have a 14 stack, which we used to be limited to a 10. Now, if we try to move, well, we can't move on a lay stone or a standing stone. If we pickups seem to be busted on a stack order member 33. Really? What? Huh? Why does it crash here? Our member doesn't have an X position, but I thought when we populate our members, gosh, control find members, thought we'd give ourselves 10 members, or 14 members. Yeah, we do it right here. We give ourselves a max stone height. Do we have to... No. Shoot, man. We didn't try to move from a 14 stack, did we? Before we moved on from it. Well, we've got that amount of members. We populate them nil. Huh. So does that mean an 11 stack would also crash us? How did that crash? Must have accidentally typed that. Right now there's a 10 stack. We just put 1 on there. Try to move. Oh, come on. Really? Give me a break, dude. We don't even have, we don't have stack control. We don't have stack control. Why the amount of members would control whether or not we're in stack control or not. It's because right here, we only update our stone control and stack control for 10 stones. So if we put in our max stone height instead, we might be okay. See, why does that happen? Why does that happen, man? Oh, God. What are we doing here? The members should have... Not max stone height. No, it is that. Max stone height. Shoot. Okay, what if we go to our max stone height, replace it with a 14. Does it still crash? We do have stack control now, but that's so jacked. That's so jacked. Why do you do that? I think it might be something to do with the tester stones. I don't know. 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, can we move from an 11 stack? No, we can't. Remember? 33. Field X is a nil value. I'm gonna replace these. Now member 33. Field X is a nil value. So for some reason, our self X is not initialized. We don't have a member. These are all members. We don't have a member. I'm pretty sure we do have a member for our 11th member. It should not be nil. Yet I'm not seeing where we do it. Right here. Yeah, we should have. Why is it breaking? Now we can move a 10 stack, no problem. Yet, we have an 11 stack. All of a sudden, our member is a nil value. Our field X, which is the first field of our member. No, the third field of our member is nil. Well, third parameter, I guess. Now it gets initialized, not even as nil. Okay, I see. No. That's not nil. That should be limited to 5x5 2D array. I don't know why it's nil. I'm kind of curious if we turn off that stuff, if it totally jacks. See, that's the same problem. What if we just say that this is 1? Super jacked, but I'd expect it to be. But it didn't crash. What this is saying is populate 10 members worth. Not even 10 members worth, 14 members worth now. 14 members worth. Into each member. Yeah. Into a table at an index. Okay, so we're giving ourselves 14 members, instantiations within each occupant, and we have a 5x5 creative occupants. I don't get why it would be nil. I don't get why it would be nil. We must be doing another 10 somewhere. That shouldn't be affecting it. I don't know. I don't think that's going to fix it. Hey, that fixed it. What the heck? That allows us to move. What was that doing? What? That was just updating our mouse stone position. Okay, yeah. So once we picked it up, since our mouse stone member gets assigned to our stack order, our stack order was something higher than 10, and we were only doing 10. Okay, so I guess that fixed it, but we still have that sneaky bug, which is, look at this. If we're moving a stack here, and we say, hey, let's move it right here, and drop a stone, and then drop another stone, and drop another stone, and hit enter, it stops rendering. Oh, see, look, that's it. That's the problem. The legal move highlight doesn't get flushed when it swaps. So legal move highlight of our movement origin needs to get flushed upon dropping our last stone. So we need a flush. Why aren't we flushing legal move highlight upon? Yeah, we just need to do that. We need to flush our legal move highlight upon dropping all of our stones. So the code here, what is the first movement movement 4 is the first time we can dump all of our stones. So movement event 4, when we hit enter, we need to flush, and we are flushing it there. It just, I guess, isn't getting flushed. That's weird. It doesn't get flushed if we dump in a second movement, but it does if we do it in a first movement. So let's see where our legal move highlight is getting flushed. We do it under clear control, and we give it an occupant. Well, no, that's different. Okay, so yeah, we flush it. This is what it is. We flush our legal move highlight. See, now we want to flush it. Shoot. I think we want to flush it regardless of the occupants. Because enter is pressed, we just want to flush that bad boy. So instead of, oopsie, what if we turn it off here and we flush our legal move highlight upon an enter press? God dang. We flush our legal move highlight upon an enter press in a move type 4. And then we want to do it in a movement event 5 as well. It's actually right when we swap players. So we can instead put it right before we swap players. We're gonna say, actually, this should be in our player swap reset. So player swap grid reset, do we not reset our legal move of our origin space? Come on. Player swap grid reset. We are not. So we need to do that. We will say we flush our legal move highlight of our movement origin grid to be false. That should fix the problem. So, okay, as soon as we hit enter, that green movement origin should never be green again, which it's looking like it fixed it. Let's try each move type. Cool. It's looking like it's worked. No matter what movement we end up dropping, either all of our stones in our first movement, second movement, third, or fourth, it seems like it is resetting appropriately. Yes. And we are able to pick up from a 14 stack. And our adaptive sizing still works. Nice. And we've got same color stacks, which is really nice. Cool. If we take a look at our get diff, we changed our string size because we're adding a max stone height variable. We're giving ourselves 4 more stones than we were able to. We're rendering the border now for our colors on our lay stones, so you can see a white on white and a black on black. We change all of our for loops to be, instead of 10 members, our max stone height members, so that's a little more adaptive. And then we added a flushing our legal move highlight to false upon a player swap grid reset function, which should have been there in the first place. But yeah, I want to find this playstate render 971. Playstate render 971. And I just wanted to put a space here. And then we'll commit this. So we'll say commit with a message saying we increased maximum stone height to be 14. Added render, added border render to laystones, and we fixed a bug, and we flushed movement origin highlights in our player swap function. And we'll push that bad boy. Okay, so We ended up doing a couple features today instead of more bug hunting. We did fix a bug anyway, though. But tomorrow we're going to be doing more extensive bug hunting. We do need to... You're kidding me. What are you talking about? You were just working. What? Why would this be? Bro, we were just working, no? Okay, I don't know why that was busted. I don't know why that was busted, but it was a mistake. So yeah, we need to add we did this, we added our outline. We did this. No moves, can't recreate. Yeah, we need to do that. I feel like we implemented this already. I don't exactly remember though. Let me see if or I need to type down that we need to legal move gets false if all surrounding spots have capstone or standing stone. We need to do that because you can hard lock the game that way. So that's another important bug. And then we also need to worry about prevent player from dropping 15th stone on 14 stack. Now that entails quite a bit of things, because if there is standing stones all around, except the bottom, for example, all around your movement origin, and the space beneath you has 14 stones, then we need to say for sure don't make it a non-legal move for you to pick that up, because your only legal move would be to dump stones on a 14 stack, which should be impossible. But it goes further than that, because if you've already locked in your first movement, if your next movement is onto a stack of 14 occupants, we need to prevent you from doing that as well. So we need to add some off-grid, which is the variable we use to prevent our player from dropping in the next grid. So we need to ask before we switch to our next grid, you know, if our next grid is a grid with 14 occupants, then we need to become off-grid true so that we force the player to hit enter by dropping all of their stones. And then on top of that, we need to just do our overall debugging a bit more, because we were able to crash it by playing for X amount of time, and then it just gets stuck, and then there's no way to reset the board or reset the turn. So we should probably add a button to reset the turn, so that in case the game is stuck for whatever reason, because you can't drop a stone somewhere, or for whatever reason, that you can hit a button and it will undo your stone pickup. That's a lot of work. I'm thinking about all the stuff that goes into that, and that's going to be tricky, but we just don't, we don't want our players to be playing and then get stuck and then have to just completely quit the game. So ideally we do add something like that. But yeah, we'll keep chugging along, and we're in the home stretch. We're doing really well. We're almost to the point where we could focus on win state and then polishing it up. We've got a couple more bugs to hunt, a couple more conditions to prevent, and then we can work on the win state. Yeah, looking good.